Welcome to our lesson on solving two-step equations part 2. Please make sure that you have a piece of paper to write on and that you write out all of the questions as well as the work that I show as well. Let's go ahead and get started. I want you to try these two questions on your own, so go ahead and pause the video, try these questions, and we'll go over them together. All right, hopefully you got the same answers that I did. So in the first problem, the very first step, I'm going to, of course, use my strategy, SADMAG, the opposite of order of operations, in order to solve this. SADMAG, so I see an addition, I'm going to reverse it using subtraction. If I subtract 9 on the left side, I'm also going to have to subtract 9 on the right side. 9 minus 9 is 0. So on the left-hand side of my equation, I'm left with 3/5 W equals negative 1 minus 9. I would leave change opposite, so you can literally do that, leave change opposite. Or if you can understand that in your head, you don't have to show that work. Negative 1 plus negative 9 is negative 10. Now, in my next step, I need to get rid of the multiplication of 3/5 times W. I need to reverse multiplication, which would be division. But we know that we don't actually divide fractions. Instead, we multiply it by the reciprocal. So that is the work that you're going to show. You're going to show that you're multiplying that side by the reciprocal, 5/3. And you're also multiplying this side by the reciprocal, sorry, these are really small dots, by 5/3. So on the left-hand side, everything here cross reduces. So you're left with just W equals. And then we can't cross reduce anything here, so we're going to say negative 50 over 3. And that's it. We want to leave things improper because when we go back to check our work, we want to just have an improper fraction to operate with anyways. So if I go to check my work here, 3/5 times W, negative 50/3, plus 9, it should equal negative 1. Let's go ahead and check that. The 3's cancel off and become 1s. The 5 becomes a 1. The negative 50 becomes a negative 10. So now I have negative 10 plus 9 should equal negative 1, and in fact, it does. So I've checked my work, and it works. Make sure that you wrote out all of my checked work notes, as well as the question and the notes that we used to write out the problem. Okay, now the second problem that you tried on your own. This is a little bit of a tricky problem because it says negative 9 minus 4m. We aren't used to seeing it like this. So let me rewrite the left-hand side of the equation over here for a moment, just to show you a little bit more about this problem. In this problem, if I want to rewrite it so that the negative 4m comes first, I would have to do a leave change opposite since subtraction is not commutative. This problem is actually negative 4m minus 9 on the left-hand side. So as a result, instead of minus 9, what I would be doing to both sides of the equation is adding 9. Now, adding 9 is the same as subtracting a negative. So either way, this cancels out. Negative 9 minus negative 9, or negative 9 plus negative 9, negative 9 plus 9. Either way, that cancels out. So I'm left on the left-hand side with negative 4m equals 12. From here, I'm going to get rid of my multiplication, so I'm going to have to divide both sides by negative 4. And you find out that m equals negative 3. Now, because this problem was tricky with the variable coming second, what I would like to do is go ahead and check my work. So, negative 9 minus 4 times negative 3 should equal 3. Let's go ahead and try it. Negative 9 minus 3 times negative 3, which is negative 12. And we would do a leave change opposite, and in fact, we do find out that it works. Okay, on to our next couple of problems. Eliminating a fraction. Now, this isn't a true fraction. This problem, and I want you to write this out, and I want you to also write out the problem. Now, the top of this problem and the bottom of it looks sort of like a fraction, but it's really not. When we think about SADMAG, the opposite of order of operations, so SADMAG, we always use SADMAG to solve any type of equation. The top here is what we called in class party on top. It's a grouping. It's a type of group. And the bottom, because of this line, is actually truly division. So when I go through SADMAG, subtract, add, I know that I don't see any of those. Even though I see an addition sign, it's really a grouping. It's not an add. So I can't get rid of the plus 3 at this time. Multiply and divide, though, I do see this division by 4. So the very first step in this particular problem is that we're going to multiply both sides by the denominator. In other words, I'm going to multiply both sides by 4. When I do that, when I multiply both sides by 4, this is really 4 over 1, so these cancel out. And then the right-hand side becomes a 32. So it's going to say x plus 3 equals 32. So again, my first step was multiplying by 4 because this symbol in here wasn't wrong button. This symbol in here isn't actually a plus. It's part of a grouping symbol, so we weren't going to get rid of that first. Okay, so now I'm left with just a one-step equation. X plus 3 equals 32, and I solve for the variable like I normally would. What I would do is subtract 3 from both sides, show that this cancels out, and then my answer, x equals 29. If we go to check it, so here's me checking my work, 29 plus 3 divided by 4 should equal 8. 29 plus 3 is 32. Divided by 4, we do find out that equals 8, so I know it's the correct answer. All right, a couple more problems. I'm going to go ahead and do the first one with you, and then I'll have you try the next two on your own. So in this problem, we need to scan it and see what's happening here. I do see a subtraction sign, but don't let that fool you because it's actually part of a grouping because of that fraction bar right below it. So really, currently what I have is a grouping and a division. So I'm going to have to get rid of the division first by multiplying this side by -6 and this side by -6. If I multiply something by -6 and it cross reduces, I'm just left with the grouping that was on top, x minus 5 equals 10 times -6 is -60. Now my next step is to add 5 onto both sides, and then I get x equals -55. And if I go to plug that back in, of course, I will find out that it works. -55 minus 5 is -60. Divided by -6, positive divided by negative is a positive, so 10 equals 10. I see that it works. Okay, go ahead and pause the video and try these next two on your own, and we'll go over them in just a moment. Okay, hopefully you got the same answer that I did for these. The very first step that we are going to do is multiply this side by 3, multiply this side by 3. Because the top was a grouping, the only other option is to get rid of the multiplication first. So then I'm left with 7 plus b equals -27. Now I want to reverse the addition of 7, so I'm going to subtract 7 from both sides. And I'm left with b equals -34. Again, if I check my work, 7 plus -34 over 3 should be equal to -9. -27 over 3 does, in fact, equal -9, so I know it works. And the very final problem on this page, the first step is to multiply both sides by -2. That will cancel this off over here. X minus 4 equals 6/5 times -2 over 1 is -12 over 5. And now I'm going to have to add 4 to both sides. The tricky thing about this is that we need to add a fraction that's negative with a whole number. So I'm left with x equals -12/5, and instead of plus 4, I'm going to say plus 20/5, because 20/5 is equivalent to 4, and I needed a common denominator. So my final answer here, -12/5 plus 20/5 would be 8/5. And hopefully you got that answer as well. Okay, last problem looks really complicated because it's got all these, decimals involved. So what we're going to do first is we're going to take a look at doing the regular SADMAG order. And so I'm going to subtract 5.25 from both sides. and I'm left with 0.24 x equals negative. Now this is really a negative plus a negative. So negative 12.48. Sorry. Now I'm going to divide both sides by 0.24. When I do that, I don't expect anyone to know that in their head, so you're going to have to set up a long division problem on the side. First number in the house, so 12.48. Second number outside of the house, which is 0.24. Anytime that we divide decimals, we need to have a whole number on the outside. So we are going to have to bump the decimal over twice and twice. So my new number on the outside is 24. My number on the inside is 1,248. 24 does not go into 1, does not go into 12, but it does go into 48. And it will go in 5 times. 5 times 24 is 120, so I'm going to subtract 120. 124 minus 120 is 4. Drop down your 8. And then 24 goes into 48 2 times with no leftovers. Which means that my answer here would be x equals negative 52. Now, I'm going to show you a shortcut for that problem. That could be a little bit confusing. What I want you to do is try multiplying both sides by 100 and then resolving the problem. So, in other words, we're going to multiply this, oh no. We're going to multiply this entire side over here by 100. I'll use distributive property and then multiply this side by 100. Okay, when we multiply by 100, remember the trick here is to just bump over 2 decimal spaces. So this would be 24x plus 525 equals negative 723. Now I'll solve like normal. Subtract 525 from both sides. And we get 24x equals negative 1,248. My next step would be to divide both sides by 24. I'll move this so you can see a little bit better. And now it's going to say x equals. Now, if you look back at this problem, this was the same exact problem, 1,248 divided by 24. So my answer is still negative 52, but it's, the only difference is that in the second problem, I avoided working with decimals at all. So what I want you to do is write a 2-sentence or so explanation as to what just happened. How did I get the same answer the second time around, but it was a lot quicker and easier? And that will be what we go over first thing tomorrow. Thanks for watching. Have a good night.